Everybody, let's try this problem. So we're trying to find the axial forces here, here, and here. So this is suited to the method of sections. So I'm just going to cut a section right through there. Okay, and now we have two options. We can pick the top section or this bottom section. Totally up to you. But just note that when you draw the free body diagram of this section up here, it'll look something like this, right? But then this section here will look more like this. And then there are these supports, the pin over here and the roller over here. Okay, so this section has 6 unknowns. This one has 3. So totally up to you, but I think I would prefer to analyze the section with less unknowns. This one. I mean, these are the 3 unknowns, and then these are the loads, which are given. Okay, and then let me label these. So BD, CD, CE. And then, okay, let's see. For the geometry, this angle, I'll just call this theta 1, and I'll call this theta 2. So theta 2, like for each of these members, it's all the same, right? This angle is the same as this angle. And then it's just like one big triangle, right? So it's just, I'll just jot it up here. Arctangent of this triangle, right? Opposite over adjacent. So that's 8 over 6. Okay, so we got this angle. Theta 1, just make note that if you take a look, this angle, this angle, this angle, they're all different, right? If you just look at it. So we just want this one over here. So this triangle, it's going to be opposite over adjacent. So this is 2. And how far is this? It's not labeled, but we know that here to here is 6. And then see how these are all even like this? Kind of messy, but right? So this, each of these has got to be 1/4 of 6 meters. So 1.5, right? In other words, here to here is 1.5, right? Here to here is 1.5, here to here is 1.5, here to here. Okay, so there we go. We got the geometry. Now we just write 3 equations for those 3 unknowns. Okay, so x direction, we got these 2, and the x component of that, negative TCD cosine theta 1, plus TCE cosine theta 2 equals 0. Y direction, minus TBD minus TCD sine theta 1, minus TCE sine theta 2. And then let's sum torque about anywhere we want, somewhere clever where we get rid of unknowns. I think right here, right? So that's point C, because then if we sum torque about point C, neither of these forces provide any torque about this point. Okay, so then there's torque from this, and then the lever arm here to here is 1.5 TBD. The torque by this force about this point is 0. The torque by this force, see the line of action over here? This lever arm is 2 meters minus 2 meters, 10 kilonewtons. Okay, so then let me point out the unknowns here, 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 here. Okay, so we got 3 equations, 3 unknowns. Which one would you like to solve first? This one only has 1 unknown. So you got TBD. Got it? So then you can put that number right over here. And then all you're left with is these two equations with two unknowns. So then you can just do substitution. So just pick one or the other. For example, like this one. Write it in terms of, let's say, TCE. TCE cosine theta 2 is TCD cosine theta 1 minus 24, right? And then just divide the whole thing by cosine theta 2. So this is TCE, and then you take this and substitute it right here. So then when you write this equation here, it's minus TBD minus T, sorry, wrong place. Over here. I circled the wrong thing. Okay, so I'm writing this equation right now. Minus TBD minus TCD sine theta 1 minus TCE sine theta 2. And TCE is right here. TCD cosine theta 1 minus 24 kilonewtons over cosine theta 2. And if you look at this equation, it only has one unknown right here. Because we already solved for this right here. Right, the answer is 20. 20 divided by 1.5. Okay, so then solve this for the one unknown. Now you have this answer, and this answer, and this answer. So the only one left, TCE. So then you take your answer, TCD, plug it in right here, and then you got your third answer. Okay, so I hope that's helpful. See you on the next video.